Good morning, my dear student. Welcome to the GSM Polytechnic. In this video, we are learn about the AC fundamental. It is very much important topic of electrical technology subject, which is very much and very good number of question is coming in the your lateral entry examination. So we are start our session. Today we are discuss about first point, single phase AC signal AC circuit, generation of single phase AC signal, and some important topic parameters such as cycle, frequency, RMS, etc. Okay. Now, before going to the brief discussion, first try to know what is the AC signal and what is the difference between AC and DC. What is AC signal? AC signal means alternating current. That means the current or quantity which changes position with respect to time is known as a alternating current. Suppose look at this curve, that is 0, that is pi, that is pi by 2 pi, and this is a 3 pi. Okay, this is our signal. So this is the respect time t, and this is V, voltage. Okay, this is voltage. So the current change his position from positive half cycle to negative half cycle, again negative half cycle to positive half cycle. So it is starting from 0, then it is increase, and this is the maximum value, then it is decrease, and this is the 0, then again it is increase, maximum point reach, then it is decrease, again increase, reach maximum point, then decrease. So it is called alternating current. That's mean the position, that is the current are changed with respect to time. Now what is DC? DC means the value remain constant. Value remains constant. Look at here, the value remains constant overall time duration. Okay. Now another difference between AC and DC signal, that is AC signal have some specific frequency. In AC signal, frequency is 50 Hz in India, and DC signal frequency is 0 Hz. Okay. Now another important difference between AC and DC signal, that AC signal we got instantaneous value, but in case of DC we not got any instantaneous value. And then question is, what is the instantaneous value? Suppose this is the, look at our curve, this is alternating signal, then we start from 0 to increase the value 0, it is the time duration 1 2 3 4 5 6 7 8. From each point we get a specific value. Suppose that is 1, we get the value is here, it is the specific value. Second, it is specific value. Third is specific value. And each point have specific value. So this value is called instantaneous. This value is called instantaneous. But in case of DC, there is a overall constant, so there is a no instant value, there is no change of value. But in case of AC signal, the value is changed from the 0, that is 0, then it is increase, and 0.1 max here, this is the point, and again increase, then reach the maximum point, then it is decrease. So we got in specific value for each and every portion. Then what is AC circuit? That is first page. What is single phase AC circuit? Single phase AC circuit nothing but a connection between source to load through a single path. This is called AC, single phase AC circuit. Now very important another parameter, that is generation of first phase AC signal. So now we discuss how to generate. Okay, actually there is a one formula, that is Faraday's law of electromagnetic induction. E equal to minus n d phi by dt, where n equals to number of turn and d phi by dt means the rate of change of flux. Okay, if we produce a relative motion between a uniform magnetic field and a set of conductor, then our EMF are produced. I am again said that if we produce a relative motion between uniform magnetic field and a set of conductor, then EMF produce. Here we use a magnet, permanent magnet, that is N, north pole, and here another south pole. Okay, this is north pole and this is south pole. Now through this pole, this two magnet, we are try to produce uniform magnetic field produce. Okay, and we know that if two magnet remain opposite, so it is attract each other. So line of force are line of force are moved from north direction to north pole to south pole. So it is the magnetic, these dotted are represent magnetic line of force. Okay, now a conductor, that is AB, are placed between two pole. A conductor are placed between two pole A and B. If we move this conductor, between magnetic field, then EMF are easily produced. There is a two way how to produce EMF. There is two way. If we move the conductor between this magnetic field, or we fix the conductor and move the magnet, both magnet, then EMF produce. Okay, the formula is E, that is Faraday's law, equal to minus of n d phi by dt. Suppose this is the our one magnet and it is another magnet, and this magnet produce opposite polarities. So here this is dotted, represent the line of force. Okay, now one magnet is produced. One magnet is produced between them. Suppose this, look at this position, that is, this is the first position, A and B. Okay, in this position N and B means the magnet does not move and conductor does not move. So both are rest condition. So there is a no EMF are produced. Okay, if we try to move this conductor, then line of force introduced to the conductor and EMF produced. Suppose this is the first position, that is conductor remain reset position, so there is a no EMF are produced. Okay, now another position is here. This conductor are tried to move. Conductor are rotated, but magnetic field is fixed, magnetic flux is fixed. Okay, now the another position, that is position 2, that is conductor is rotated. In this point, the number of line of force is more contact with the conductor. So if more number of line of force connect with the conductor, so means d phi by dt are increase. So if d phi by dt are increase, then also EMF are reduce, EMF are increase. Okay, if d phi by dt, the rate of change of flux is increased, then E is increased, মানে EMF are increased. So previous case that is remains reset condition, মানে rest condition. So there is a no flux is linked with the conductor, so EMF is not produced. But in second case, second position, the the amount of flux link with the conductor is more with compared to previous, so the EMF is more produced. Now it is another position, that is position 3, that conductor is perpendicular with the is previous position. So in this position, maximum number of amount of flux is linked with the conductor. So maximum flux, maximum EMF of induced. So look at here, from this, from 0 point, that is rest condition, মানে previous first condition, the EMF not link with the conductor, so there is a no. Then second condition, the EMF are induced, EMF are increase, so curve is starting from 0, then it is increase. And this point, that is where the conductor is perpendicular, then it is reach the maximum value, then then it is the maximum. Now another way, if AB again in the rotated in reverse direction, so reverse direction, so we compared to the previous direction, the link is, flux link is reduced, then EMF also reduced. So here, from here, the voltage starting to reduce. Now in this point, that is AB, that is conductor are in remain horizontal with the but opposite polarity, that is A here A and B, and but previous case here A and B, so polarity change, so the here the value is remain 0 because it is rest condition. After this point, conductor again conductor again move, again try to move or again rotate, so here A, it is here B, so here A and B, it is rotate, here A and B, so maximum, so the amount of flux linkage is increased, so so the waveform also increase. So in this way, in this technique, the EMF are generate. So in this way it is generate. Okay, now it is 0, so it is pi, it is 2 pi, and it is 3 pi. So in this curve, it is reach the maximum point, that means here it is maximum, reach the maximum value, same as here is maximum value but opposite direction. Okay, now here is reach the maximum value, so this point is called peak value. It is also called peak value. Okay, maximum value, that is represented by E max or V max. It is minus E max because opposite direction, or V max. Okay, so it is the process how to generate a single phase AC signal. Okay, thank you.